Is the Earth flat or spherical? Did people in the Middle Ages think that the Earth was flat? Now, the reason we have to ask this question is because we often hear that people did not know that the Earth was spherical until Columbus sailed west trying to get to India. Or sometimes you'll hear it said that people did not know that the Earth was spherical until Galileo proved it. Now, that's actually not the case. People knew that the Earth was round and spherical long before Columbus ever sailed trying to go west, and long before Galileo ever got interested in astronomy. Now, to begin with, we have to understand what the definition of a sphere is. A sphere is a three-dimensional object where every point on its surface is equidistant, which means it has the same distance from the center. To illustrate this, here's an example of a sphere. Here you have 2 points on the surface, A and B. If you draw a line from A to C and measure that distance, it will be equal to the distance from B to C. Every point on the surface has the same distance from the center. That's the definition of a sphere. Now, how did they first discover that the Earth was a sphere? There was a Greek in the 5th century B.C., his name was Anaxagoras, and he discovered the cause of solar and lunar eclipses. He discovered that a solar eclipse happens when there is a new moon, which is the phase of the moon where it's all dark, and that moon blocks the sun. He also discovered that a lunar eclipse happens when the Earth comes in between the sun and moon. So he concluded that the moon reflects the light of the sun. Now, about a century later, Aristotle took this up a bit further. He made the observation that the shadow on the moon during an eclipse is curved, and that shadow is the shadow of the Earth. Therefore, the Earth is circular. But he also found another piece of evidence that the Earth is a sphere. He found that when you look at the stars that are seen on the horizons, which means you look straight ahead of you, those stars' positions differ based on the latitude that you're on in the planet. Let me illustrate what this looks like. If this sphere is the Earth, and you have star 1 and star 2, if you're standing at point B, and you look straight above you, you'll see star 1. It will be right over your head. But if you look straight ahead of you, straight ahead to the horizon, you'll see star number 2. If you're standing at point A on the Earth, you will never be able to see star 1 because it's out of your field of view. You can only look as far as this way, and that means you'll see star number 2 straight ahead of you. But let's pretend that point A is the country of Greece. And I'm going to go south to Egypt here by moving south on the globe, which is actually what Aristotle did. He moved from point A, and as he kept moving south, he noticed that the position of the star in the sky that he saw on the horizons started moving ahead over him, so that if he looked a little bit further up, those stars were overhead, or they had risen above the horizon. Now, it wasn't that dramatic, but he noticed they rose above the horizon. So let's pretend I move all the way down here between point A and point B in the middle. This star that I could see from point A on the horizon and from point B on the horizon is now overhead. Notice that's the property of a sphere. You're walking on a curved surface. So the second part of his argument was that was a property of a sphere. The position of the stars changing based on where you are on the planet. So he concluded that the Earth is spherical. And he wrote that in his book on the heavens, book 2, chapter 14. There was another Greek about a century after Aristotle, and he noticed something peculiar. He noticed on the summer solstice, which happens in late June, which is the longest day of the year, and the day that the sun moves farthest north in the sky, in 2 different cities in Egypt, something different was observed. In Syene, which is in southern Egypt, the sun was directly overhead, and for that reason there were no shadows that day. But on the same day in Alexandria, which is a city in northern Egypt, about 668 miles north of Syene, the sun was not quite overhead. it cast a shadow. So he made the conclusion as well that the surface of the earth must be curved. Otherwise, the position of the sun should have been the same over both points on the earth, straight above, but that was not the case. Now, about 2 centuries after that, another Greek living in Egypt called Claudius Ptolemy gathered all known astronomical knowledge of the ancient Greeks into a book called the Almagest. In that book, he described an object called the armillary sphere, how to build it and how to use it to observe the stars based on your position on the earth. And that was from Book 5, Chapter 1. Now, what's important for us here is that that object depicts the earth as spherical. This is a 3-dimensional object, and in the center, the earth is a sphere. It was used for 1,600 years and shown in paintings before Columbus. Here is a copy of that book from the year 1279 AD. This object in the hand of this scholar is the armillary sphere. Now, what does that sphere look like close up? It looks something like this. Notice, the earth is in the center and it's spherical, because the Greeks knew that the earth was a sphere. And when? We're talking about 350 BC, almost 1,700 years before Columbus. Here's a painting from the year 1476, before Columbus sailed the ocean blue, and it's showing an armillary sphere. Notice, the earth is in the center and it's spherical. Also here, in the year 1480, 12 years before Columbus sailed, there's an armillary sphere, and the earth is in the center as a sphere. Now, why would Columbus even dare going west to get to India in 1492 if he believed the earth was flat and made the discovery that the earth was round? The answer is because he did not think the earth was flat. He knew it was round. And if it was round, then you can get to countries in the east by sailing west. Same deal with Magellan. Magellan did not sail around the world to prove that the earth was round. He already knew that. He wanted to be the first to sail around the world by going in one direction, meaning he wanted to be the first to achieve this. He was not trying to prove the earth was round. People already believed that. Now, in the Middle Ages, besides the armillary spheres, terrestrial globes, which are the globes that we know today of the earth, both of the Arabs and the Europeans showed the earth to be round. And again, the armillary spheres with the earth in the center, just like you saw. Now, the strong early proofs that showed that the earth was a sphere were the shadows during the lunar eclipses. They were curved. Also, the position of the stars in the sky from different positions on the earth. The fact that they differed was a property of a sphere. Now, moderate proof, so not too strong but not weak, for the earth being spherical. The fact that Magellan circumnavigated the globe. Some people might doubt it, which is why it's a moderate proof. These, nobody can doubt, because people can see it based on where they are. Everyone can see the shadow during a lunar eclipse. Nobody's going to say it's not curved. Now, weak proofs for the earth being spherical are pictures. Why? Because they can be argued against in this day and age. Because we have Photoshop. We have special effects like in Star Wars where they make brand new planets. The picture's not fake. It's just not the strongest argument that you can make that the earth is round. These are the strongest early proofs, because nobody can dispute them. Have someone go out, watch a lunar eclipse. They'll see a curved shadow. Have someone travel a little bit, and they'll notice the stars in the sky shift their positions. But this picture, among all the other pictures that show that the earth was round, was never meant to fully convince people that the earth was round. Rather, this was simply the expectation of what we were going to get if we got high enough above the earth, because of the thousands of years of knowledge that the Greeks had started building and had provided evidence that the earth was round long before there were cameras or space shuttles. Thanks for watching. Until next time.